Assalamualaikum and a very good day. So now we go further for differentiation and integration topic, which is now we are in week 13 part 2 video. Now we will learn the topic on maximum and minimum. We have learned before this to compute a gradient, we need to differentiate function. Now we need to know the trend at dy dx. When here we have, if dy dx greater than 0, then we can say that our y is increasing. But if dy dx is less than 0, so y is decreasing. Here we can see, for this example, here dy dx, it is less than 0, means that here the value is negative value. So we can see the pattern of the graph here, it is decreasing. And then for this part, it is, for example, dy dx is greater than 0. When dy dx here greater than 0, then y here, the curve y here will be increasing. But for this part, dy dx is less than 0, so it will decreasing. So we can see we have, for this turning point, it is minimum turning point. Here is maximum turning point. We can relate further differentiation, which is dy dx, either it is less or greater than 0, with nature of the solution at turning point of the curve. If the gradient is positive, so we have here uphill slope. So the slope will be going up. If we have here negative value of gradient, so we have downhill slope. The slope will be going. Now we want to check. We mentioned previously about the critical point. Suppose C is the critical point. We want to check the nature of our solution or the nature of the function at this critical point. We will use here first derivative test. If f prime changes from positive to negative at C, means that here from positive to negative at C, then f has a relative maxima at C. To understand further, let's go to this table. Let's say we have here a point C as a critical point. When x is less than C, then our f prime x is a positive value, means that the slope will be uphill trend. And then for x is greater than C, and then our f prime x is negative. So the slope will be downhill trend. Here when we plot, we'll got this kind of curve. That is, this one is point C. At this point, we call it as relative maxima. Or also, we can say that it is maximum point at this C. And then we go to the second possibility of this nature of the critical point. If f prime changes from negative to positive, now negative to positive at C, then f has a relative minima, or here we can say that it is minimum point. Let's say we go to this table when x here is less than C and our f prime function is negative value. So the slope here will going down. And then if x here is greater than C, which is for this one, we compute this f prime x, it is positive value, means that it will have a trend upward. When we plot here, we got this is our C, so this one going down, this one going up, means that we have for this C, it is minimum point. And then if f prime does no change in sign at C, then f has no relative maxima and also no relative minima at C. For example, here in this table we have when x less than C, our f prime x is positive, and also it is positive when x is greater than C. We can see for this one, the slope will going up. For this one, the slope also going up. So the graph actually is just like this, means that there is no relative maxima or also no relative minima. To understand further, we go now to the example 1. We want to investigate our stationary point. Stationary point here also refer to critical point. So, in this example, we need to find first the stationary point at fx equal to x squared minus 8x plus 3, and then we determine its nature. We have two questions here. The first thing, we need to find our stationary point, and then we need to determine its nature. You need to know that stationary point means that the point where we compute our f prime x and we make this equation equal to 0. It is like that. You find, for example, if I have quadratic function, it is find roots of equation. But now we want to find the value of f prime x, not the value of fx. The value of f prime x when our the value of x when our f prime x equal to 0. So how to compute this? The first step now, you need to find f prime x. We have this one as our function. When we compute f prime x, it equal to 2x minus 8. And then how to compute stationary point? Based on this one, we need to make this equation equal to 0. When we make this equation equal to 0, we can solve this for x. That is, when we solve this one, we got x equal to 4. This x equal to 4 is a stationary point, or also we call it as critical point. And then we need to check or determine its nature. How to determine its nature? You have to plot a table. You have to draw a table. So here we have in our table, if you refer to the previous concept, x, f prime x, and also slope. So our x here, what we need to put here actually, this part we put our critical point, which is x equal to 4. And then at this part is refer to any negative value that is here x. If we remember, it is less than c. So in our case, any value x less than 4, or we can write as 4, which is at negative side of 4. And then here for this one, if we refer back to the table, it is a value x which is greater than c. In our case, c is 4, so it is a value x which is greater than 4. Or we can write it 4 at positive side. For this one, when we compute our f prime x, okay, in this case, you can see you can take any value of x which is less than 4. And you need to substitute that value in your f prime x. Remember, in your f prime x, not in your fx. So let's say I choose here x equal to 3. Okay, let's say I choose for this part x equal to 3. I substitute in f prime x, so I have 2 times 3 minus 8. You can see here 6 minus 8, that is less than 0, which is this one is negative value. When negative value, the slope will going down. But at 4, when we substitute this 4 in this one, of course, it will equal to 0 because we find 4 by make this equation equal to 0. So here, at, at 4, the slope will be just straight line like this. But at 4, on positive side, means that here you can substitute any value which is greater than 4. In this case, let's say I substitute in our f prime x, f prime 5, which is equal to 2 times 5 minus 8. Here we'll got equal to answer 10 minus 8, which is equal to 2, that is greater than 0. Means that we have here a function of f prime x, which is positive. When it is positive, means that gradient is positive. So our slope will be going up. In this case, you will have pattern like this. This is our critical point, which is at 4. So here, what we can see in this case, this at stationary point x equal to 4, we have a minimum turning point. This is how can we investigate stationary point. So first, in this question, you need to find the stationary point and then we need to determine its nature.